Welcome back to Robot in 3 Days at the University of Waterloo. I'm Nathan.
I'm Julian, and this is Ragnar, and welcome to our robot overview and what we've learned over this past weekend.
First, we're going to talk about our drivetrain. This year we decided to go with a West Coast drive. We reused our gearboxes from last year. We have a 28 by 22 inch frame dimensions made of 2x1 box tube. We used 6-inch pneumatic wheels which help us get up onto the step, and we have a 4-sim single-speed West Coast drive gearbox.
So for our hatch mechanism, we decided that intaking from the ground and along with the loading station would be beneficial for us and advantageous for us when we're playing the game. So we decided on a Velcro kind of mechanism where the Velcro interfaces with the hatch when it's all the way down from the ground and also in the upright position from the loading station. In addition, we added pistons on the arm of the mechanism that actuate the hatch onto the cargo ship and as well as a lower level rocket. The design of the arm is through the bumper, and that is so that we can intake from the ground and also intake from the loading station right up against the bumper. We wanted to go with this design so that when we're depositing onto the lower level rocket, we don't have to worry about that bumper gap. We found that if we had the bumper gap, it would be really hard to put the hatch onto the lower level rocket, but not as hard as doing it onto the cargo ship. So just a little bit more about the mechanism itself. The arm is a 21-inch 2x1 box tubing, and it comes down over the bumper so that the mechanism can deploy onto the hatch and the cargo ship. It has 2 pistons with 3D printed caps so that it fully interfaces with the hatch and can push it off pretty effectively. It is powered by 2 775 Pros on 101 gear reduction, or gearbox, so that it has the right amount of torque to go down and back into the upright position. We have a mechanical hard stop at the back so that it prevents from hitting any electronics or the other mechanism. And as I mentioned before, it can intake from the ground and the loading station. And one other kind of design constraint was that it had to start within the frame perimeter, and that's why it's kind of on this angle right now, so that it fits that mode.
Next, we're going to talk about our cargo mechanism, which also is the face of Ragnar. For our cargo mechanism, we decided to go with an over-the-bumper top roller intake. This rolls the cargo into the mechanism so we can secure it with our robot. Next, the mechanism rotates upwards so that we can shoot the ball into the cargo ship, bottom of the rocket, and the middle of the rocket. In order to achieve this, we use 2.5-inch Coulsons on our front roller that compress the ball 1/2 inch when it's held in our mechanism. These Coulsons are run by a 10-to-1 gearbox on a 775 Pro. The rotation of Ragnar's head is done with a 100-to-1 gearbox with an extra 2-to-1 chain reduction with a 775 Pro. Finally, we added a hard stop to ensure it doesn't hit the hatch mechanism. Next, we're going to talk about the mechanism that allows us to achieve a level 2 half climb. So we use our hatch mechanism as a way to prop the front of our robot up onto the scoring level, and then we use the rest of the robot to drive up to that level. How that works out is this mechanism with its 2 100-to-1 775 Pros actuates down, lifting the front of the robot up. Our back bumper is lifted up with our back wheel shifted backwards. This allows us to keep contact with our back wheel for as long as possible. Then we drive our robot as far up as we can, and finally we swing our cargo mechanism up to here to shift our CG to the front of the robot. This allows our CG to be centered far enough this way that our robot can get up to the level 2 half. So for the electronics, we mounted all of them onto this
this plate over here. We did this so that in the event we were going to a competition, the electronics board would be easy to access and easy to see. So we have, like I said, all the electronics mounted here. And for our pneumatics, we have an onboard compressor with one air tank along with these two pistons. And we wired the tubing through the box tubing inside here, just so that we avoid any pinch points that happen with the hatch mechanism. And also, for our battery placement, we chose to put the battery lower and towards the front of the robot, so that we shift our center of gravity towards the hatch mechanism, so it assists in our level 2 climb. So thank you guys for keeping up with us here at the University of Waterloo for the past robot 3 days. But before we go, we do want to leave you with some tips that we found to be really helpful and could help you guys in your upcoming build season. So first of all, make sure your game piece is inflated to the correct 13 inches. When we got our game piece, we inflated it to only 11 inches and found this to be really wrong. So make sure that your game piece is 13 inches in diameter.
Yeah, it's also really important that you're testing your mechanisms early. Through early testing, we found different faults and were able to combat that. And we also were able to find areas where our robot wasn't strong enough, and we're able to strengthen those areas before moving on.
Another tip that we also found to be really helpful is driver practice. Even in the short amount of time we had, we saw that through driver practice over the past 2 days has greatly benefited the driver's skill in operating the mechanisms and playing the game in general. So even if you don't have a practice field, try to find one around you and take advantage of it. Driver practice is extremely important if you want to have a good competition season.
Yeah, and for our final tip, it's really important to read the bumper rules closely. We had a small mix-up and got the wrong pool noodle size, so unfortunately ours aren't legal. Make sure you're reading the bumper rules closely so that when you arrive at competition, you can get lots of practice in on the field. Thank you guys all for watching. Good luck with your seasons, and see you next year.